All right, section 8 notes fractional powers. So exponents that are a unit fraction, like 1/2 or 1/3, have a root of some kind. So as we talked about, a unit fraction means that the numerator is 1 and the root, that is your denominator, that has any number. So 1/3 of an ounce, 1/2 of an ounce, 1/5, 1/4, 1/6, whatever it might be. So our example here was that if Alice eats 1/2 ounce of cake and eats another 1/2 ounce later, we know that that would be the same as Alice eating 1 whole ounce of cake. And so we have to ask ourselves, though, what is 2 to the 1/2? Well, we know that if she has that 1/2 ounce of cake and the 1/2 ounce of cake, they need to be the same value. So x times x must equal 2, which is 2 to the 1st. If we were to work this out, we would have x times x, which is x squared. And we can ask ourselves, now, if I wanted to undo this, I'd be asking myself, what times itself is 2, or that would be the square root of 2. Similarly, we can do the same work for having a 1/3 ounce of cake. So, continue this on that same area. We'd have Alice having a 1/3 ounce times a 1/3 times a 1/3 would be the same as Alice having that 1 full ounce. So here I'd be having 3 values all multiplied together equaling 2. And again, we could write that as x to the 3rd. But now, instead of asking the square root, we could say, what math operation here? It's asking yourself what times itself 3 times. So you can change the root to be whatever this exponent is. And so in this particular problem, it would be the 3rd root or the cube root that we would be looking for. And so we need to generalize this. And that's where we were just a moment ago. We need to generalize this. So if Alice has, or Alice eats, base A cake, and she's going to have 1/q ounces. Okay, she's going to have 1/q ounces of this base A cake. So this fractional portion of a cake where it's a unit fraction, so we know that it's a 1. So a moment ago we said if it was base 2 cake, we would, and it was a 1/2 ounce, we were going to have the square root. So this root is going to be the portion or the fractional part of that full ounce. So if we have Alice having 1/q or 1/q ounces of cake, we know that she would grow by then the q root of A.
We use a different letter instead of Q.
No. So we have Q is our root. So if Alice eats, so remember this is similar to, let's say Alice eats 2 to the 1/2. We said that was going to be equal to the 2nd root of 2. But this root can be anything. So if on now you've probably filled up that full portion where it says section 8, flip the page in your notes. And directly above where it says section 8 continued, let's go ahead and fill this in. So this symbol right here is called a radical. Most of us call that a square root sign because we don't, when there is no number in the check mark area, it's a 2. And that's what most of you are the most familiar with. But just like I showed you, the Q can go there. Any number can go here. So Alice can have any fractional part of that ounce. Okay? And so the number sign here, this number, it's called the index or the root. Index or root. Okay? That number sign. And again, if there's no number there, it's a 2. Make sure you get this all jotted down. Again, so this you would say is a square root sign. This would be a third root, fourth root, fifth root. So we need to make sure that we know how to say these, and we'll practice that here together. So it's kind of just like the place that you would be like running a race. They got third, fourth, fifth, sixth. However you would say that place in a race, like that's how you would read these. So if Alice has, again, it's a base X cake. She has 1/2 ounce. We're going to practice 3 examples where we have a fractional exponent. We're going to convert to radical form. So we need our X is going to be the base. It's going to stay underneath. The root is the denominator, which is 2. And this 1, that's your power. But notice we don't have to have the 1 there because something to the first power is just that something. And we don't have to have this 2 in the check mark area. So simply writing the radical sign with an X is the same thing. So on the next example, X to the 1/3 is going to be the third root of X. Can everyone repeat that? Third root of X. Please do not say to the X, because as soon as you say the word to, it makes you sound, it implies that you're writing an exponent. So it's the third root of X. The next one, how would we read this? Say it one more time. Fourth root of X. You all are going to have the opportunity to read some of these out loud in front of the class, so make sure that you understand how to say them. All right, so sometimes we're going to practice going back to the other format. So right now we are in radical form, and we need to go back to exponential form. So first of all, notice that there is a 1 here when it's not, because you are going to have a numerator. So if there's no number there, you put your 1. Anything underneath the radical sign, that's your base. So if it's more than 1 number, like on all 3 of these examples, we want to use parentheses to say that, hey, this whole chunk came from underneath the radical sign. So we're going to place 25x to the 5. It's a little bit hard to see.
Yeah.
To the 5th. We're going to place that all underneath, or all in the, pink papers. Thank you. We're going to place those in parentheses. And so again, the 1 we added, and the root is the denominator. Okay, simple enough. We're just practicing converting back and forth. So then on this next example here, we have the square root of 16x to the 7th. Notice I said square root because there's no number here. What number do we add? 2. The 2, and the power that's not there we add is the 1. And so at an exponential form, we're going to implement parentheses again. 16x to the 7th, all to the 1/2. So the root becomes the denominator.
Ms. Wall, in that first example, you forgot to get fifth power.
Oh, thank you. Yep, I did not write that all up there. Any other questions or comments so far? Okay, so then on this third example here, again, we're going to use parentheses. 27x to the third, y to the 12th. Everything that's underneath that radical bar, put it together. And our exponent here is going to be the 1 power that's there. So this is all going to be to the 1/3 power. All right, so 3 now examples. We're going to practice evaluating. Whenever you see the word evaluate, it might say simplify. So sometimes if the base is like a variable, it might say simplify. Evaluate means that you're going to be able to get an actual answer. But so the word, when we have fractional exponents, simplify and evaluate, they're kind of interchangeable a little bit. Okay? So to evaluate or simplify, and you're starting in exponential form, we need to convert to radical form. So your pink sheet is going to help us get our answers here. So 9 to the 1/2, we want to write as radical form, is going to look like, who could read this for me? Who could read this before we get the answer? Square root of 9 or second root of 9. Perfect. And so, and I think most of you know what this answer is, but humor me and look at your pink sheet.
25.
Okay? So look at your pink sheet. The root is the column that you need to look at. Okay, I'm not talking about your pink notes paper, but your actual power sheet. Look at the second column. So that says exponent at the top. Look at 2. So we're in that second column, and then you scan down until you see the base, which is 9, and then you go over to the left and see what the answer is, and you see that it's row 3. Okay, so that means that you're asking yourself, what squared is 9? And the answer is 3. So again, you probably knew that without using the pink sheet, but most of you might not know what times itself 3 times is 125. So again, we're going to write this in radical form. So the third root of 125. And scanning on that pink sheet, again, you're going to go now to column 3. Scan down until you see 125, and then go to the left and see what row you're on, which is what? 5. Okay, and then for the third example, right there, that's all the examples you would need for like the next little activity that we're going to do in class, the Stranger Pieces of Cake worksheet. So let's go ahead and evaluate this next example. We'll practice more like this at the end of class. So we have 8x to the 24 all to the 1/3. So to evaluate this, we're only going to put the 8 in the radical symbol. So if my directions weren't evaluate, I would rewrite this problem as the third root of 8x to the 24th. However, I can't take the third root of x to the 24th. I simply want to kind of simplify that part. So I'm only going to put the 8 in the square roots, under the square roots or the cube root sign. And I'm going to go ahead and just write times my x to the 24th, but it is still to the 1/3 power. So I'm going to put it in parentheses to the 1/3. So off of our pink sheet, we can find out what to the 3rd power is 8. 2, correct. What to the 3rd power is 8 is 2. And now this x to the 24th to the 1/3, we can use our exponent rule. Power to power, multiply. And so 24 times a third, and if you think about it in context of Alice, it's saying, hey, she's having a third of that 24. So 24 divided by 3 is 8. So my final answer here now is 2 times x to the 8th. And again, we will do more examples like this in the section 9 notes before we do the fractional exponent worksheet number 2. So let's pause here and do the worksheet, stranger pieces of cake.